Hey guys, we're Group 3. This is our landfill design project. We started with the first 4 alternatives, A through D, and then came up with 3 of our own. So we started with a landfill that is being unused, and we wanted to make sure that none of the water flow goes through the landfill and enters into the river. So we looked at the heads and the river outflow to find the best option.
So this is part A, this is the base case. The landfill is around row 25 and column 25, so it's in the middle. And the heads are higher in the top left-hand corner and lower in the lower right-hand corner. So this is going to be the direction of flow, and this is what we're trying to avoid because the water is flowing through the landfill and into the river in the bottom right-hand corner. This is the case that we're going to be comparing to with our other alternatives.
So this is the summary of the mass balance for the base case before any other features are added. The main value that we're looking at when we look at all the other alternatives is the outflow from the river that has a value of 0.16 cubic feet per second. So that's what we will be looking at with the future alternatives.
This is our second alternative, Part B. This will consist of the cap only. The cap consists of an impervious cover larger than the limits of the actual landfill. So this will prevent any surface water from draining through the ground into the waste area.
As you can see on the left is the initial time step of the cap only alternative, and on the right we have the last time step of the cap only alternative. As you can see, the head values are still pretty similar to the base case, and that's because this impervious cap only prevents surface water from entering the landfill area, and it does not prevent the groundwater from moving through the landfill area.
As you can see from the mass balance summary, the river outflow at the beginning with the cap is very similar to the original base case outflow, but at time step 20 it decreases very slightly. Again, this is over the course of 600 some odd years, so the amount that it decreases is pretty negligible.
This is our third alternative, Part C. This includes the cap and wall. So this time, as well as the cap, we have a wall penetrating into the ground until a certain depth. So although it does stop some of the groundwater from flowing through, it depends on the groundwater depth and if it will go underneath the wall and still flow through the landfill area and to the river.
As we can see by comparing the initial time step to the final time step, while there is groundwater within the walled area initially, by time step 20, basically all of the groundwater is being diverted away from the landfilled area by the wall.
So again, looking at the river outflow, you can see that the initial time step has a value of 0.157 cubic feet per second, which is slightly lower than the initial base case value of 0.16. But if you look ahead to time step 20, you can see that the outflow to the river decreases significantly, much more so than with just the cap.
This is our fourth alternative, Part D. This includes the cap, slurry wall, and drain. So now we have the cap, which reduces the recharge into the site, the wall, which reduces discharge of contaminated groundwater, and the drain, which carries away the discharge.
Looking at the time steps for alternative 4, you can tell that the head values look similar to alternative 3, which was just the wall and the cap. However, what we know based on the implementation of drains is that the groundwater in the walled area initially is now going to be taken away by the drains rather than flow into the river.
As you can see, the first time step for this alternative is 0.153 cubic feet per second, which is again slightly lower than the base case. Over the 600 years it takes to get to time step 20, it does indeed reduce reduced significantly and has the smallest river outflow of any the alternatives so far. As you can see, the outflow from the drain also decreases significantly over the time steps.
So now moving on to our own alternatives. For part E, we decided to do a well and a cap. So we placed the well at the top left-hand corner of the landfill area in order to try and prevent any water from even reaching the landfill at all.
Comparing the time steps of this alternative, the heads didn't really change much from just the cap-only alternative. The well didn't really do much in moving the heads, and the well resulted in dry cells, which are not desirable.
As you can see from this alternative with the cap and the well, the initial outflow from the river is very similar to the scenario with just the cap, as is the outflow at time step 20. It doesn't change much over time, much like the one with just the cap.
Moving on to our second alternative, for part F, we decided to do 2 walls and a cap. So we put one wall on the north side and another wall on the west side of the landfill and capped the entire area. So since we saw that the well in the previous alternative did not give us the greatest benefits, we decided to go back and look to see which alternatives provided the most significant change that we wanted. So that's why we decided to put the 2 walls and a cap to reduce the river outflow as much as possible.
So specifically looking at time step 20, we can see that the wall is effective in diverting the water away from the landfill. This results in a constant head in the landfilled area, and the water that is going to the river is clean water and was not contaminated by the landfill.
So looking at this alternative with the 2 walls and the cap, you can see that the initial outflow from the river at time step 1 is very similar to the base case from part A, but over the 20 time steps, the outflow from the river decreases significantly to 0.008 cubic feet per second, which is by far the lowest outflow of any of the alternatives. The previous low alternative was the case with the walls, the cap, and a drain. So getting rid of the drain actually helped decrease the outflow from the river.
For our last alternative, for part G, we decided to look at 3 sides of the wall and a cap. This time, since the 2 walls did so well, we wanted to see what a 3rd wall on the east side of the landfill would do and if it would reduce the river outflow at all.
Looking at the time steps for this alternative, we can tell it looks pretty similar to the 2-walled and cap system. However, the main difference that we see is that the heads on the east of the easternmost wall decrease, and similar to the other alternative, there is a constant head within the walled area.
Given that the best scenario thus far was the case with 2 walls and the cap, we decided to see if adding a 3rd wall, if the added benefits would outweigh the cost of the 3rd wall. As you can see, the initial time step, the outflow from the river is close to both the initial base case as well as the case with just 2 walls and the cap. At time step 20, the river outflow has decreased significantly compared to the time step 1, but it still has not decreased as much as the scenario with 2 walls and the cap. So the 2 walls and the cap is still a more effective solution.
So our preferred alternative is alternative F, which was the 2-wall and cap system. If we're just comparing the 2 most effective alternatives, that would be this system and the fully walled, fully capped, and drain system. However, this alternative was more effective in reducing outflow to the river than that other alternative, and it would be cheaper since it doesn't have as many features as that alternative. The reason this alternative was so effective is because it keeps contaminants from reaching the landfill by blocking it off in the direction of flow.